Let's do the last section. Synthetic division, the factor and remainder theorems. What we're going to deal with here. Okay. Synthetic division is going to lead us to the factor and remainder theorem and how we can do that. Synthetic division is a way of dividing without using long division. Okay. Synthetic division can be used with linear divisors. That means, for example, x minus 5, 3x plus 7, 2m minus 1. Those are linear divisors. So it has to be that. We can't use synthetic division if we're dividing by x squared minus 4, because that's not linear, it's quadratic. So synthetic division can only be used when you're using that. So that's, you're like, well, if we can do this with synthetic division, why would we learn long division? Because long division is useful when you're dividing by a larger polynomial. Synthetic division is only useful when we're doing linear divisors. So really small divisors. But they're strategic in certain ways, okay? So synthetic division is pretty easy, okay? So we're going to start with example A. Just start learning how to do that. Some of you may have done this before. Some of you may not have done this before. But it is an important skill, okay? So here we have a division problem. It is set up in fraction form, which is pretty commonplace for this course and algebra courses in general. But we're talking about dividing that. And, we don't want to factor the numerator. We're going to use this x plus 2 to do that division with that. So we want to do it with synthetic division because I can, and it's much easier than long division. A lot less multiplying happening, a lot less subtracting in places you can miss signs and everything with the synthetic division. So what you want to do to set up your synthetic division is set the divisor or not divisor equal to 0 and solve. So our divisor is x plus 2. If we set that equal to 0 and solve it, we're going to get x is equal to negative 2. That's important. We're going to use that in just a second. Okay. The next thing to do is set up your synthetic division. And this is how I do my synthetic division. I make like this laying down L shape, just like a box. And then I put a little shelf on the outside. It's almost like playing hangman or something. Not quite. But, okay. Now, here's where that number that we got over here, x equals negative 2, is important. It goes on the shelf. So on the shelf is how I refer to that. I don't think that's exactly, you won't find that in a textbook anywhere. They don't call it a shelf. It's your divisor, okay? But I say that's on the shelf. Now, inside of this box is going to be the coefficients of our polynomial we're dividing into. So that's the numbers. No letters, which is good because the letters make it confusing, right? So we're going to put a 5, the negative 6, the negative 28, and the negative 2. And it's like 4 individual columns is what that's like, okay? So we have a column that's got the 5 in it, negative 6, negative 28, negative 2. If there's a missing piece, you would put a 0 in its place. So we got to start with whatever the highest power of x is the first column, and go down from there. If there's one missing, put a 0 in its place. Even if it's the constant on the end, put a 0 in its place. Okay? Now, the first step every time you do synthetic division is drop the first term down. Every time. Then you're just going to multiply 5 times negative 2. That's negative 10. It's what goes there. And in synthetic division, you're always going to add. So that it's synthetic. It does the same thing as long division. It's a little less complicated. You don't subtract. You do the opposite. You add. Okay? So -6 plus -10 is -16. Then you multiply again. -16 times -2. +32. Add. That'd be +4. Multiply again. 4 times -2. -8. Add. That last number is always going to be your remainder. Okay. Here's what synthetic division does. Since we can only divide by linear pieces in synthetic division, what it does is it takes this third degree polynomial. It's got x cubed in it, it's the highest one. This one has x to the first power. It breaks it down by 1. So we started with x cubed. The quotient is going to be 1 less x squared. So this creates the answer to our division problem. It's 5x squared minus 16x plus 4. And then here's where our remainder comes in. Plus -10 over x plus 2. Really smart Greek people. They didn't have Facebook and Twitter and TV back then.
Is there another name for this besides synthetic division?
Synthetic substitution. That's all I've ever other. I don't. That's the only things I've ever heard it called, but there may be another name that somebody else has used. Lindsay.
So can you put -10 over x plus 2?
Yes, that would be legal as well. Yeah, you could do that. Yeah. I usually just use a plus sign in the front, no matter what the sign is, and then just.
I mean, just because you use it as like a group.
Right. All right, so let's look at another one. Let's say we're doing synthetic division for -x to the 4th plus 3x squared minus 4x minus 5. I'll put that in parentheses. This should be a fraction. X plus 3 on the bottom. Now I'm going to go ahead and set up. Don't have any missing pieces. I got it. Do I have a missing piece? I do. I need a 0 in the x cubed position. X to the 4th, x cubed, x squared, plain x, plain number. What goes on the shelf? -3. So that comes from setting x plus 3 equal to 0 and get -3. Now, what's the first move? Bring my -1 down. Now what? Which is 3. 3. Good job. -6. Be 18. Be 14. It's all right. You're doing it now. It'd be -30 and -42. So your remainder for this problem is what? -47. So let's write the polynomial that is. -x to the 3rd, 3x squared minus 6x plus 14 plus -47 over x plus 3. Or Lindsay wants to do -47 over x plus 3, which is fine. It's absolutely the right answer. Actually, probably closer to like what your Blackboard assignment would probably be like. Well, it's equivalent expressions. Makes you think a little bit.
It confuses me.
Yeah, I understand. Yeah. Yeah. Okay. Now, this the first two examples we've had a remainder in here that was a number. Well, if the remainder is 0, then that makes that a special polynomial division. Okay, and that's what the remainder and factor theorem. Theorem. If the remainder is 0, then the divisor, what you're dividing by, is a factor of the polynomial. The value is also a 0 of the polynomial. We're going to see some example. That means x-intercept. So what we're building up to is next week we'll take synthetic division and use it to help us find the zeros of higher degree polynomials. Or find the x-intercepts for those. Just like we found them with quadratic formula, we used, in the quadratic, we're going to use synthetic division to help us find them for larger polynomials. So let's look at a couple of these. And this week, I'll tell you what one of them is. We're going to decide if K, quote unquote, they use the letter K, I don't know why, is a 0 of f of x. Okay? So here's our polynomial. F of x is equal to x to the third minus 4x squared plus 9x minus 6. And they say K is equal to 1. That's a semicolon there, not an I, semicolon. They're telling us K is equal to 1. All right? Now, where did that K come from? It came from the x minus 1. That's where that K value is coming from. Okay, it's like what we're doing is like we're dividing this polynomial, x to the third minus 4x plus 9x, or minus 4x squared plus 9x minus 6. It's like we're dividing it by x minus 1 is what we're doing. Yes, that's what that means. That's what I'm saying, is that the k equals 1 means we're dividing by x minus 1. That's what that means. If it were k equals -1, we'd be dividing by x plus 1. That's what that means, okay? We'll see that as we do some examples here. All right, so what we're going to do is we're going to set up synthetic division for this problem. You got a 1, a -4, a 9, and a 6. No zeros to put in on this one because it started with x to the third. It had an x squared, it had a plain x, and it had a plain number. On the shelf is where k goes. +1 goes on the shelf. If we get 0 as the remainder, then that means 1 is a 0 of the polynomial. It means x minus 1 is a factor of the polynomial. Okay? So let's do synthetic division with that and see what happens. -3 multiplied by -3 again. That's 6. That's a -6 there in the original top part. I didn't write it down correctly. So that'd be +6. And what do you know? The remainder is 0. It's like you meant for that to happen. What that tells us, this means that k equals 1 is a 0 for f of x. 1 is an x-intercept. It also means that x minus 1 is a factor. A lot of stuff comes from that remainder being 0. Okay? If that remainder is 0, all of this stuff is now true. That 1 is a 0 for f of x. And also, you could, if I did f of 1 here with function notation, I'd just plug 1 in for x here, I would get 0 out of that. All of that comes from this happening and the remainder being 0. A lot of stuff. That's a heavy theorem that carries a lot of weight in algebra is that remainder being 0. If that remainder is not 0, none of that happens. Okay, so what we're looking for is whether or not these are zeros. Okay. The significance of it is that now we have x squared minus 3x plus 6, and then x minus 1. We've partially factored the original polynomial, and we could find the rest of the zeros by taking this thing and setting it equal to 0 and solving it. It's quadratic, so I can use quadratic formula to get the other zeros. So what we're building up to next week's lessons are taking that step, getting a 0, and then taking what's left over and breaking it down further and getting the rest of the zeros, finding all the places that original polynomial crosses the x-axis. That's the significance of what we're doing, is we're getting the skill set, the tool to be able to do that later on. We're not going to go ahead and do that tonight. We'll do that next week. But that's what we're building up to, is being able to get that synthetic division done so that we can do that. Okay. All right. So let's look at this function. X to the fourth minus 2x cubed plus 4x squared plus 2x minus 5. And then k is equal to -4 is what we want to check. We want to know, is -4 a 0 for that polynomial? Okay. So I'm going to do my synthetic division. It will look just like that. It'll say, determine if k is a 0 of f of x, or of the function. And it'll look just like that, just typed out instead of written. Okay. And then, so we're going to put a -4 on the shelf. 1, -2, 4, 2, -5. Run that through. Be -112. Now, it's obvious that this is not going to be a 0 at this point. That's -110, 440. So the remainder is 435. Is that 0? No, not a 0. Because that's, all right, so I ran my synthetic division with a -4. 1 times -4 is -4. Add to -6, multiply 24. Add 28. Multiply. Add. Multiply. Add.
I was confused because I thought that it was supposed to be 4, but that was in my head as the x minus 4.
Yeah, it should be, if that were a 0, then the factor would be x plus 4 for that. Yeah. So when they give you k, that means, oh, that's what I'm using on the shelf. Okay. So 435 is the remainder. So that tells us that k equals -4 is not a 0. That's what that tells us. Okay. All right. Hang on just a second. Get this one that does. All right, so let's do example E. Let's use the same polynomial. F of x is equal to x to the fourth minus 2x cubed, 4x squared, plus 2x minus 5. And let's check k equals -1 this time. Running that through, 1 times -1 is -1. It's going to be -3, and then 3, 7, -7, -5, +5, and there's the 0 that I'm looking for. That right there tells us that k equals -1 is a 0 of 4 f of x.
So we're really on this one. We're really not worried about getting the other numbers.
Yeah, we're not.
As much as we're worried about getting 0.
Exactly. That's exactly right. We're not worried so much about getting the rest of the problem, but we're worried about whether that's a 0 or not. That's what we're after on this part.
So on the quiz, if it's not a 0,
There'll be some yes nos.
okay.
Yeah, I got A and B choice. You know, like is it 0 or is it not? So it's like a yes or no type thing. Now next week we'll go further with it, and you'll have to actually find the rest of them, and we'll see how to do that. All right, so let's look at one, and let's say we had here's our same function. Let's just use the same one because it really doesn't matter. X to the fourth minus 2x cubed plus 4x squared plus 2x minus 5. And I'm going to check k is equal to 1/2. So it's a fraction that I'm going to check. No, don't turn it into a decimal. So up on the shelf is going to be that fraction, 1/2. The reason you don't want, this one, would it do any harm to turn it into a decimal? Probably not, because it terminates its 0.5. But if it was 1/3 that we were checking, definitely can't turn that into a decimal because you can't write enough 3's down. Yes. And you think about how many operations you're doing here, and if it's inaccurate on the very first one, how inaccurate is it going to be on the very last one? It's just going to grow out of that. So got to be careful of that. It's kind of like some of y'all are like going in the nursing program and things. If you mismeasure the big bottle of medicine, it could cause you to mismeasure all your dosages that you're putting out there from there. So that you don't want to round at any point here. So we want to leave those as fractions. So let's run a fraction through here to get the experience of it because it's fun. So the 1 comes down, 1/2. -2 minus 1/2. How much? -3/2. -1.5. What do you mean? You multiplied 1 times 1/2? Oh, not. Oh, so -2 plus 1/2. -1.5 math, enter. Leaving that as -3/2. And multiply those two together. We get a -3/4. 4 minus 3/4. Math, enter. 13/4. Multiply. Be 13 over 8. Add 2 plus 13 over 8. Math, enter. 29 over 8. And then multiply. Be 29 over 16. Negative 5 plus 29 over 16. Negative 51 over 16. So is 1/2 a 0? Okay, not a 0. That's what we're checking. Okay. All right. So when we were solving quadratics, sometimes we had the non-real solutions. We had imaginary or complex numbers as answers. That can happen with larger polynomials as well. And sometimes they're going to ask you to check to see on a function x to the 4th minus 2x cubed plus 4x squared plus 2x minus 5. They're going to say k is equal to 1 plus 2i. It's a complex solution. And we got to check that with synthetic division. Oh dear. But it's not that bad. It's really not. I'll show you how to do one of those. So set it up, and on the shelf, it's going to be that complex number. Now, the difference in these and the others, you want to leave yourself plenty of room in each column because you're going to have to write a complex number underneath each number at some point. So I'm going to make it a little longer here, and I'm going to put my coefficients 1, -2, 4, 2, and -5. So I'm just making it a little longer because I know I'm going to have more stuff there because it's a complex number. All right. Process is still the same. You're going to drop the 1 down and then multiply. The difference is you're going to have to distribute. 1 times 1 plus 2i would be 1 plus 2i. And then you're adding. So -2 plus 1 plus 2i would be -1 plus 2i. And then I have to multiply that times 1 plus 2i. So that's where I got to do a little scratch paper work and do some simplifying. Or I could do this with my calculator. Y'all remember that the calculator will do that stuff. Parentheses 1 plus 2i, those parentheses, -1 plus 2i. I get -5. Man, what in the world? That's nice. That's what goes there. Don't forget your calculator can do those things. We did that back a month ago, maybe. It's been a while. Okay, so don't forget that you can type that straight into your calculator and get the I stuff done nicely for you. And then we're just adding those together. 4 plus -5. That's back to a regular number. It's -1. And then we would run -1 times 1 plus 2i, which would be -1 minus 2i. So that leaves us 1 minus 2i there. And I have to multiply that 1 plus 2i times 1 minus 2i. So I would, take the benefit of the calculator, 1 plus 2i, and then 1 minus 2i. Let it help you. It's +5 this time. Which is really awesome because that means that 1 plus 2i is a what? It's a 0. Okay. One plus 2i is a 0 of that because the remainder was 0. Next week we'll learn some more things about what that does. What's that? Since 1 plus 2i is a 0, 1 minus 2i is also a 0. There's this theorem that says that always happens, and it does. And we would be able to go further from there. But next week what if they don't give us K is the name of the game. We got to figure it out. And I'll show you some nice ways to do that. It's not real bad. Okay. All right. So on this section, page 305, 1 through 57 would be a good smattering of problems to look at for that. And I'll give you a good idea of that. Blackboard quiz has got 38 questions on it. You got till next Monday at 5 to do that. I know that in the last couple of times we've had Blackboard assignments, folks are waiting until Monday to do both attempts. Folks that are not doing that are doing better than you. Okay, so that's because they're getting an attempt in and fixing their problems before they take it the second time. So I would advise try to get your first attempt in sometime this week, and then second attempt on Monday is fine. But don't. I think you're scrambling trying to do both of them on Mondays. Okay, so anyway, you're dismissed for tonight, and we'll go at it again next week. Is the last lecture of the semester. Yay! And we go from there. Okay, y'all have a great week. Email me if you got questions.